Once again, you're welcome to Secure Academia. If you've not subscribed to this channel, do it to subscribe to get more notifications on our subsequent videos. At this moment, we'll be looking at some exercises on sound waves, which is more like a continuation of our previous video on sound waves. I believe you've watched that, you've watched that video, and of course understood the concept of sound waves. All right, so if you have your writing materials, take down the first question. The length of a violin is 50 centimeter and the frequency is 500 hertz. Full stop. Calculate the speed of the waves in the string and the wavelength in air. Full stop. In bracket, it says speed of sound in air is equals to 3.44 meters per second. Alright, so we'll be solving this question right away. Okay, so the solution to this question. Now basically we are given parameters, we are given the length to be 50 centimeter. Okay, and of course we have to convert it to meters by dividing by 100. So when we divide by 100, we have 0.5 meters. All right, so we have a frequency as well of 500 hertz. Okay, so basically the formula we are going to use is F equals to V all over 2L. All right, F equals to V all over 2L, and of course the frequency here is 500 equal to the V here is unknown. All right, so V is equals to 2 times 0.5. If we make V sorry to a formula, V will be equals to 500 times 2 times 0.5, and that will give us 500 meters per second, because 2 times 0.5 is 1, so 500 times 1 is 500 meters per second. All right, so that is V1 is equal to 500 meters per second. Now the question is that we should calculate the speed of the waves. All right, so this is the first parameter we should look for, V1. All right, so we are progressing. Now after looking for our V1, now the next thing we are now supposed to do is to look for our lambda 1, all right, which is our wavelength. So lambda 1 will be equals to V1 all over F. Remember that the V is equals to lambda F. Wavelength and frequency is equals to the velocity. Remember that formula. So this will be equals to 500 all over 500, and it will give us 1 meter. So the wavelength is 1 meter. Now V2, remember V2 is 3.44 meters per second. So V2 is the speed of sound in air that was given in the question. All right. So which is 3.44 meters per second. So remember that from V equal to lambda F, all right, V is directly proportional to lambda, right? Okay, so if V is directly proportional to lambda, it means that we have V1 all over lambda 1 equals to V2 all over lambda 2, right? Okay, so we are looking for the second wavelength is the speed of the waves in the string, all right, and the wavelength in air. So we have gotten the speed at first, okay, which is that V1 that we at the V1 rather, that we solved, and we got 500 meters per second. So now it's for us to now calculate the wavelength in air. Okay, it's for us to calculate the wavelength in air now. All right, and the wavelength in air will be represented by lambda 2. Okay, because we have V1, we have V2, and we have the first wavelength. All right, remember that the first wavelength is the one that we calculated by dividing V1 by F. All right, so at this point we will now substitute our parameters. So it means that if we make this sort of a formula, lambda 2 will be equal to lambda 1 V2 all over V1, and that will give us 1 times 3.44 divided by 500, which will be equal to 0.688 meters. All right, 0.688 meters. So that is the answer. So that is the speed of the wavelength in air. The speed of the waves is of course the one that we first calculated, all right, as our V1, which gave us 500 meters per second. All right, so that is one question. Now the second question we'll be looking at, okay, take down. A string has a length of 3 meters. A string has a length of 3 meters and a mass of 25 grams, has a length of 3 meters and a mass of 24 grams. If it is subjected to a tension T of 500 newtons, find the velocity of transverse waves on the string. Alright, so these are our parameters. But now our mass now is in 24 grams here. Okay, 24 grams. We have to convert it to kilograms. Alright, we have to convert it to kilograms. So basically more often than not in physics, our mass usually like representing is best to represent it in kilogram. So this will be 24 over 1000, which will be 0.024 kilograms. Alright, so 0.024 kilograms. That is the mass. So now basically we are told to look for velocity. Alright, and velocity is equal to, in this case now, it is the tension all over mu. Alright, so this mu here is more like the factor of the density of the material. Alright, so basically how do we get it? It is basically mu is equal to the mass all over the length of the material. Alright, and it's expressed in kilograms per meters. Okay, kilograms per meters. So it's almost like the density of the material. Alright, so now basically we have to now divide our m, which is of course we converted to kilograms, 0.024. When we divide it by our length, okay, remember our length is 3 meters. Okay, our length is 3 meters. Then our answer, so if we divide 0.024 by 3, you'll be having 0.008 kilograms per meter. So these are mu. Now, so to get our V now, remember is the tension all over mu. So to get the velocity of the transverse wave, so T all over mu, the tension that was given to us was 500. Mu that we got is 0.008. Okay, so the square root of 500 over 0.008 will give us 250 meters per second. So that's our V. Okay, so that's our V. So basically, these are a couple of questions that are most likely to be seen in a potential um, examination that has to do with waves and optics. Alright, so we'll be taking another question quickly. Now, calculate the frequencies of the first three harmonies of a piano string of length 2 meters if the velocity of the wave on the string is 1.4 meters per second. Alright, 1.4 meters per second. So let's do that quickly. So we are told to calculate the frequencies of the first three harmonies. So we are looking for like F1, F2, F3. Alright, and we are giving the length to be 2 meters in the question, and we're giving velocity to be 1.4 meters per second. And we are told to look for F1, F2, and F3. Now, I'll give you the formula that will enable us to look for F1, F2, and F3. So basically, the first harmony, F1, alright, will be equal to F naught, and the formula for F naught is V all over 2L. That is the normal frequency. Alright, V all over 2L. Remember when we used it in the previous question that had to do with violin. Alright, so this will be 1.4 divided by 2 times 2. Remember the length is 2 meters. So this will be, if we do that, now we'll have 1.4 divided by 4. So that will give us 0.35. Alright, so that will give us 0.35. So 1.4 divided by 2 times 2. Alright, so we'll have 0.35 hertz. Alright, 0.35 hertz. Okay, so now the next one, our second harmony F2 will be giving us 2 F naught. So it's just basically 2 times 0.35. Alright, so if we say 2 times 0.35, it's going to give us, sorry, 2 times 0.35, alright, to give us 0.7. So this will be equals to 0.7 hertz. Then our F3 will be equal to 3 F naught. So this will be 3 times 0.35. If we do that maths, we have 3 times 0.35. That's going to give us 1.05. This will give us 1.05 hertz. So these are the harmonies. These are the harmonies of course, these are the harmonies of the piano string that has a length of 2 meters. Alright. So if we are told to look for fourth harmony, it will be 4 times F naught. Just know that F naught basically is the frequency, which is of course the velocity divided by 2 times your length. Alright, 2 times your length. Okay. Now let's look at another question quickly. Let's look at another key question quickly. Alright. So now okay, take down take down this question. Alright. Now to measure the depth of a well, a man dropped a stone and counted the seconds between when he dropped the stone and when he struck water at the bottom. Now, if the time interval is 4 seconds and the speed of sound is 3.44 meters per second, find the depth of the well. Alright, so we are told to look for the depth of the well if a man actually dropped the stone with a speed of sound, alright, and the time interval of 4 seconds. So now let's list our parameters. In this question, we are just giving two parameters. So parameters are V equals to 3.44 meters per second, and of course T equal to 4 seconds. Alright, so V equal to, remember this another formula, that V is equals to 2 x all over t. This x can also be a. Basically, you can use it for any unknown, alright, especially when it comes to depth. So x is representing depth of the well, alright, especially when it has to do with depth, especially when it has to do with length, wideness, and all of that. So you can use any, you can even say 2b, alright, you can even say 2b, but most times it's best to use x. Alright, so x is depth of the well, t is time interval. Alright, so the v is actually denoted as of course the velocity that we are given in the question, 3.44. Alright, so the velocity or speed of sound, 3.44. So basically, x, to determine x itself, x is equal to, sorry, let me get another matter. So x, basically, x is equal to Vt all over 2, that if we make x equal to a formula, alright, which we are looking for. So we know that our V is 3 point, our V is 3 point, okay, 44 times the time is 4 seconds, all divided by 2, alright, all divided by 2. So let's get our calculator. So if we say we have 3.44 multiplied by 4, and we come down all divided by 2. So it's going to give us 6.88. Alright, so it's going to give us 6.88. So basically, it's going to be expressed in meters. So our final answer for x, that is the depth, is going to be 6.88 meters. So we are going to express it in terms of meters. Okay, so that's what we are told to actually look for. All right. So okay, let's look at another question. A police siren, a police siren has a frequency of 800 hertz. All right, a police siren has a frequency of 800 hertz. Full stop. If the velocity, so we have frequency of 800 hertz. So if the velocity of sound in the air, that is the velocity of sound in the air, is 3.44 meters per second, find the frequency heard by the driver of a velocity of a vehicle moving at 1.4 meters per second. Okay, so find the frequency heard by the driver of a vehicle moving at 1.4 meters per second. A, towards the siren, and B, away from the siren. away from the siren. All right. So basically, we have two parts of this question we are going to be solving, but it's important to state our parameters first. So we are giving V1 to be 3.44. We are giving another V2 to be 1.4 meters per second, which is of course the the frequency heard by the driver is what we are looking for. Then this one is more like the speed at which the driver of the vehicle is driving with. All right. So basically, we are going to solve that quickly. So now, first of all, stating the formula we are going to make use of here, let me give it to you. Basically, we're looking for A towards the siren, we are looking for frequencies, two frequencies. We're looking for F1, all right? We're looking for F1 and of course another frequency, all right, away from the siren, all right? So basically, let's check the first one. So basically, F it would now be equal F1 will now be equals to the F that we have bracket V1 plus V2 all over V1. All right. The frequency that we have in this question is 800. All right. So 800 times bracket open 3.44 plus 1.4 all divided by 3.44. Okay. So let us solve that with our calculator. Let's solve that with our calculator. So we have 800 800 times 3.44 times 1.4, all right, plus 1.4 rather, so plus 1.4 all divided by 3.44. Okay, so 3.44 plus 1.4 divided by 3.44, 800 times that. So it's good that we bracket this. Okay, bracket this as well. All right, although it will not change anything. So we have 1125 hertz. Okay, 1125 hertz. Now, at this point in time, it's also important for us to calculate the one away from the siren. But now, towards the siren, one thing I need you to understand is that towards the siren is going to be positive, away from the siren is going to be negative. So basically, both of them will have the same value, just that one will be positive and the other will be what? Negative. So we can simply say that our F2 we can simply say that F2 frequency away from the siren will be minus 1125 hertz. Okay, minus 1125 hertz. All right. So now, basically, that is one way of solving that question. All right. So it's expedient for us to understand the different ways of applying formulas in sound waves. All right. So the next video we are going to actually be viewing would be reflection and refraction of light. All right. So if you found this video educative, if you found it beneficial, do well to share. And of course, if you have any question whatsoever, um, ask a question in the comment box below. All right. So do well to also, like I said, subscribe so you can get notification for subsequent videos. Bye bye.